So you understand this part, right? So at the competitive equilibrium, we have full insurance, right? That part you know. So if there is no problem in information, okay, and if the market is perfectly competitive, then we will have full insurance, okay? That is the efficient one. That is the efficient case. That is the efficient market, efficient outcome. And what you are asking is adverse selection, right? Okay? Yeah. So if there is no problem knowing who's high risk and who's low risk, right? And each type will be fully insured in each of their market, right? So this is low risk person's market, high risk person's market, and each person will be fully insured, okay? This is the efficient outcome of the market. So inefficiency to the market is introduced by information asymmetry, meaning that the insured person who's purchasing the insurance knows his type, but those who sell the insurance company doesn't know the person's type. That's the source of inefficiency. And then you're asking about this picture?
Yeah, exactly.
You want to know how it works?
What exactly is point of view?
Oh, okay. Now, if I give you one additional, now if you think about it, if you look at, let's say, this case, okay, 45-degree line, okay. So this is the slope of minus 1 minus p over p, okay? P is the probability of accident, okay? So this is the case where if it's a perfectly competitive, perfect competition in the insurance market makes premium, insurance premium that the insurance company collects from the clients is equal to the P, probability of accident. Okay? If this is the case, then the insurance company is basically break even, meaning that they cannot make any excess profit because what they pay out is exactly the same as the expected payout. Okay? Which means that if they can charge the client higher than P, okay? Let's say the probability of accident is, let's say, 0.25, okay? But if they charge 0.3, then they will make profit because, they are making 5% more profit. If that's the case, okay, if that's the case, is where that this line is actually flatter, okay? So if this line is flatter, okay, then if, let's say this case is, let's say this is 1 minus pi, let's say this is the slope, okay, then actually pi is greater than p. So as long as they can charge their clients, let's say in the diagram, like a flatter line, they can actually make profit. Okay, that's what insurance companies want. Now, if you go back to this one, in this case, the case is this is the line that comes from the probability of accident of low risk type. Okay, and this is the line that comes from the probability of accident of high risk type. Okay, so which means if let's assume that they have only low risk client. Okay? Then if they charge premium along this line, they will break even. Because this comes from the probability of accident for the low risk type. And if they can charge actually inside, not on this one, but somewhere here, and if they have only low risk client, then they will make profit because they charge more than the probable accident for that group of people. Okay, now what happens in this diagram is assume that there is an insurance company, okay, that sells insurance plan P. Okay, what is a P? P is actually based on the probability of everyone. Because it's a mix of high risk and low risk, so the probable accident will be somewhere between low risk and high risk. So this is a line that shows the mixed probability. Okay? So if they make, let's say, sell a plan P, and then if everyone buys this insurance, then this company will break even. Because everyone buys the insurance, obviously the probability of accident happening for that everyone is just a mixed probability. Okay, so this is the P. Let's say this market is at P. Okay, and at P, so everyone is paying the premium that is equal to the mixed probability, and then everyone is buying this insurance. So which shows the utility of low risk type, this red one, and utility of high risk type that shows that their utility at point P. Okay. Now, what is important here is that another important point is that low risk types indifference curve is steeper than the high risk types. Okay. So when you draw a diagram, there is always region something like this because if they cross each other, then there is a like in between regions always. Now let's think of P. Okay, P. Okay, the question here is whether P is an equilibrium. The equilibrium just means that once the economy reaches this state, the economy will stay there. That's the equilibrium, basically. Once you get there, you have no reason to get out of it. That's the equilibrium. I mean, there are a few definitions of equilibrium, but there is the property of an equilibrium is once you get there, you will stay there. Okay, if it's not, it is not equilibrium. Okay. Now let's assume that P is an equilibrium. Now, but we can ask question whether really P is an equilibrium. Okay. So if it's a P is an equilibrium, then there should be no way of disrupting P. But actually, you can easily find that we can actually disrupt P. How? Think of another insurance company. Then they know how the indifference curve looks like. And then they look at the situation. Okay, this company is not making any money because it's breaking even. But I have an insurance company that sells, let's say, plan Q. This is insurance plan Q. Okay, what does Q do? Okay, once you sell this plan Q, high risk type doesn't want Q to Q. Because if they buy Q, their utility level actually goes down. But low risk type wants Q, right? Because their utility will go up. So only low risk will buy Q. Okay, that's fine. Second, the question is, then, okay, assuming that low risk type will buy Q, but is Q really a worth offering to this market? But if you think about it, as I said, if you have only low risk type, you will break even if you charge this line. But actually, you are charging more than this line, which means, okay, Q, you can make money by selling insurance plan Q, by attracting only low risk types, which means this P will disappear, right? So that's why we're saying the P is not an equilibrium. Okay? So once you pull these two groups into one plan, then there is always a way of disrupting it. Okay? So that's the reason why P is not an equilibrium. So pooling is not an equilibrium. Okay? Get it? Do you want this one again or? Okay, let's see. Yes, true.
But why then it is not the
Oh, no, I plan M. So once you get to M, it's going to look like something like this, right? So this is going to be high risk type. This is going to be low risk type. Okay? But there's the same reason. If there is another company that sells the plan something like M prime, okay, then M prime obviously will attract low risk types only, not the high risk type, and then they can make profit.
But before M prime, in the policy M, they can also have.
Yeah, they can also have profit. But the thing is, there's always a way of disrupting this M. No, so the economy will not stay at M.
But if
But actually, I mean, if you think about it, actually it depends on. Okay, yeah, go ahead.
on policy M, they can collect the premium.
Yeah, but think about it. Now, if you have a M and M prime, what happens? Only low risk type will buy M prime.
Also the premium.
The high risk type will buy M. Okay, now if you, think of M and M, let's think of M and M prime, okay? Think of M and M prime. M prime, low risk, buys this insurance because it gives higher utility. And then high risk type will keep M. They try to keep M. Okay? Now what happens is M now have only high risk type. Okay? M prime have only low risk type. Okay? If you sell M to high risk type, you will lose money. This is the probability for high risk types. Okay? Now you are selling M to high risk types, actually you are selling too cheap.
But in that graph, the most people are low risk type. Because
No, it doesn't matter. Actually, not the most people. What matters is who buys this insurance. If both types buy this insurance, yes, you can make money because this is the mixed probability. You're charging more than the mixed probability and selling the insurance to every type, then you can make money. But if somebody else sells M prime, now you will lose high risk client, a low risk client. But you have only the high risk client. And your high risk client will give so much accident, so you will lose money. Still don't get it?
okay,
No, that never mind. You know what I mean? Okay? Because if the policy M is a profitable policy, if you can sell it to both types, but it is a loss-making policy if you sell this policy only to high-risk types. So if you offer M in this economy, first you will attract both types, so you can make money because you attract both types. But soon you will have M prime. You will have a competitor that sells M prime. Okay? Then if the competitor sells M prime, you will be left with only high-risk client and start losing money. Okay? So, which means M cannot be an equilibrium. You cannot stay M when no company is trying to sell M, because they know that some other person will sell M prime, then I will lose money by selling M. So M cannot be an equilibrium. That's in short, because it is pooling. So pooling equilibrium can be always interrupted by another company that sells something like M prime. Then this company will just have only high risk client. Then they will lose money. Okay, because they cannot charge, okay, more than the high risk probability. Okay.
거기서 EUL이 P라고 그 P 있는 보험성을 하는 거.
아니, doesn't matter. It doesn't have to touch anything. It just crosses each other. Yeah. It doesn't matter. 네. Doesn't have to be. Here? Did I explain it? Oh, this is an equilibrium. Okay, why this is an equilibrium? Because it's a, think of this case, okay? Now you want to disrupt this equilibrium, okay? What can you do? I mean, what can you do? I mean, disrupt this separating equilibrium. Let's say to get rid of separate equilibrium, then there should be a way of pulling them together. Can they pull them together? Okay, the pulling them together is obviously, which means that they should offer a policy that will attract both high risk and low risk. Okay? So for example, like if they offer M, something like this, then they will pull both types, because low risk likes this, high risk likes this. However, no insurance company will sell M, because if they both types here, then probable accident will be along this line. Okay? But now they are charging too little. Okay? If they want to make a profit, they should charge somewhere here. Okay? But obviously, if you charge only here, you will have only high risk types, because low risk types wouldn't buy this. High risk, when you have only high risk types, then you will lose money, because this is the high risk type line, and then you are above it, then you are losing money. Okay? So in this diagram, if your insurance policy is below the line, below this P1 minus P over P line of your client's type, then you will make money. If you have somewhere here, actually you lose money. Here you are break even. Okay? So the question here is whether we can have an insurance policy that pools that high risk and low risk type together, okay, and which is an equilibrium. Okay, but in this case, M seems to be a way of breaking this equilibrium, but no company will sell M, because they will lose money by attracting both types. So the economy will just stay the same. Okay.
What is TL in this picture?
TL? What?
What is it in this picture, the point?
TL is the insurance policy that low risk types buys. They have, this is the plan that low risk type buys, and this is the plan that high risk type buys. So this is low risk type. So in this case, actually low risk type buys very little insurance. Okay. Okay, in this case, what we do is that let's assume there are policies. Actually, we assume that there is a policy. let's say they have FH and TL policy. And then the individual will buy this insurance, okay, and then you go through. So if the individual buys this insurance, then this is the indifference curve they have. So this is just to show the utility level of buying this insurance. Okay, and actually this is better than no insurance. Still, it's a little insurance, but it's better than no insurance. If you buy no insurance, your indifference curve will go through point N. Obviously, this is better than this. So everyone will buy this insurance if you're low risk type, if you're offered. Okay?
이거 뒤에 슬라이드에서 분리균형이었고 여기서는 있는데
네.
이게 상황에 따라 다른 건가 아니면
Actually, what matters here is actually you can easily see that basically where G is. Okay? If G is in between this point, if G is in between here, right, you have an equilibrium. Okay? If G is above this, then you have no equilibrium. Basically, in this diagram, you easily see where G is. That determines whether separating equilibrium is possible or not possible.
FH점은요, EUH랑 그 45도선이 만나는 점이 항상 이상한 거예요, 저는.
In this case, yes. In this case, yes. Yeah. Okay, if it's
저 점점이 어떻게
it doesn't have to. If it's a let me think. Yeah, it should be. Because let's say no, that the insurance company does not know who's high risk, who's low risk. But they know the probability of accident for high risk and probability of accident for low risk. Okay? So when they sell the insurance and trying to sell it to high risk only or low risk only, then high risk insurance should be on this line because of the market competition. Okay? So if they sell the insurance only to one type, then high risk type will always buy an insurance somewhere here, and low risk type always buy an insurance somewhere here. Because the insurance company knows the probability. What they don't know is who's high risk or who's low risk. They know that what is the probability of each type, but they don't know who that person is. Okay? So in this case, obviously this is a separating equilibrium, right? So in the separating equilibrium, this is an equilibrium? No, this is an equilibrium. This is an equilibrium. So this is an equilibrium, okay? So they will sell the insurance at this here, okay? TL. Oh, yeah. Because, no, okay, what matters is that if you sell this insurance TL, you will attract only low risk type. Okay? Because this line is irrelevant. You will have only low risk type. So, by competition, I mean, obviously they want to sell it for higher price, but there is a competition, so they cannot actually, at the end, they will break even. So, they will sell this. Yeah, they will break even. They are not going to lose money, but they're not going to make profit. Okay?
그러면 그 adverse selection problem을 해결하기 위해서 소셜 인슈런스를 하면은 다 강제적으로 가입을 해야 되니까 두 번째 그래프에서
네.
여기서 P에서 안 움직이는 거예요.
Yeah, basically, in this case, if there is only one insurance. So this is monopoly. Now let's think about it as a social insurance as a monopoly insurance market. No other company. Yeah, you can sell P. Okay, and actually you can sell it for higher price if you want. Okay, and then you can force everyone to buy it. So you don't have to worry about the competition or anything. Nothing. I mean, basically you are basically picking a point. Okay, on this market. I mean, this is monopoly, so there is no competition or anything. I mean, if it's social insurance, it's basically as a monopoly. Okay. Well, let's say if you allow, let's say, some people to opt out of this insurance and buy their own private insurance, then that's not social insurance anymore because it's optional. So it's not a social insurance. So that's different. Okay. In the social insurance case, actually you don't care about their types. Actually, you're gonna pull them together anyway because you will force everyone to buy this insurance plan, and then you don't have to worry about the equilibrium or anything because it's not a market. It's just law that you just do this. I mean, it's irrelevant. The market is irrelevant. Right, there is no pulling equilibrium in this market. So what's possible is only the separating equilibrium. If you allow this market to be perfectly private, okay, then the only case you can think of is this separating equilibrium. So high risk type will buy full insurance. Low risk type will buy very little insurance. Okay. So the low risk type buys very little insurance because if they buy high risk type insurance, okay, it's just too expensive. So they wouldn't buy high risk type insurance. So they will buy very little insurance.
그 그림에서 T의 자체는 보험료 수준이
The insurance price of the insurance is the same as the probability of accident for the low risk types. So the any point on this line, the price is the same.
근데 왜 그렇게 조금 드는 자기가 낸 만큼 사고가 나면은 다 돌려받을 수 있는데 왜 그렇게 조금
So, I mean, intuitively, it's something like this. You know that your probability of accident is very low, okay? So since you think that the accident is not going to happen much, so you have a very little incentive to buy an insurance in the first place. Okay? So you feel like you are wasting money. I mean, if I buy this big insurance, but this is going to happen in 1 in a million or 1 in a billion, then why should I buy that much of an insurance? It's not gonna happen. So that is the idea.
맨 처음에 그래서 세퍼레이팅 있는 거랑 방금 그래프랑 무슨 차이가 보험료를 2개를 제시하는데 그거랑 맨 처음 그렇죠. 네, 그거랑
Oh, this is the case where that the insurance company knows exactly who's high risk and who's low risk.
근데 그거랑 아까 두 개 다 보험료 제시하는 거 똑같아요. 보험료 펄시 제시하는 거. 그러면은 둘 다 풀 인슈런스로 가야 되는데.
What happens? Okay, now from the insurance company's point of view, if they sell this insurance here, they will attract high risk and low risk at the same time, right? Okay, then they will lose money. So no insurance company want to sell it above this line. Okay?
항상 좀 EUL이랑 EUH 사이에 있어야 되는 거예요, TA.
In this diagram, yes.
둘 다 안 끌어들이기 위해서.
So if the separating equilibrium gonna exist, it should exist somewhere here in between. Because once you have it here, then you have only you have both high risk and low risk, and the insurance company lose money, so they have no incentive to do so. They don't wanna sell it. Okay, but in this case it's different because they know exactly who's high risk and who's low risk. So if high risk type tries to buy the low risk insurance, they will say, no, you cannot buy this. You have to buy that. Okay. But this case, it's not possible. So they should be worried about high risk type buying the low risk insurance.
론일 때 그래프에서 맨 처음 론 타입 네, 여기서 꼭 저기 FL일 필요는 없지 않나요? FL과 N 사이면 되는 거예요.
The thing is, as I said, that the utility maximizing individual will always buy full insurance if the price is the same as the probability of accident. That's the utility maximizing choice. Okay? So if you have an option to buy full insurance, you will buy full insurance.
근데 만약에 자기 사고 날 확률이 엄청 작다고 생각하면 아까 안 산다고 했잖아요.
I mean, yeah, they are not gonna buy it for higher price like this one. I probably I gave you a wrong answer. Okay, but so the right answer here is even if low risk type wants to buy more insurance, they cannot buy it because the insurance company does not sell it. Okay. Let me check. Anyone else about this one? This one? No? It's okay? Okay. 네. Old age insurance?
로우가 R보다 큰 그림의
Oh, the other case. That's possible. Well, actually, you can. Okay, if rho is greater than R, then it's gonna look like something like this, right? Okay? If rho is greater than R, okay, then so this is the case where the rho is less than R, okay? So the blue one so this is the red one is the case where the rho is greater than R, blue is the case where rho is less than R, and white is the same. Okay.
로우가 R보다 작을 경우에
네? rho 어디 이거요? Red one?
블루가
네.
그 인디퍼런스 커브 모양에 따라서 균형이 분배가 생길 수 있잖아요.
Yeah, that's possible. I showed only one case, right? No, here, right? Yeah, that's possible. Yeah, obviously. Yeah.
그러면 만약에 C1 오른쪽에 생기는 경우는 무슨 경우라고
C1 오른쪽. Like this one, C1 2 star.
예, C1 스타 오른쪽에 생기는 건 뭐라고
I mean here. If it's steep,
사람들이 현대적으로 좋아하는 게
so if it's a steep, yeah. If it's a, let's say it's a steep, then something like this, right? If it's steep enough. I mean, this case? All right. Oh, yeah, sorry. This one is not possible because you cannot borrow from your pension. So the only possible endpoint is here.
그러면 그래프가 꺾이는 게 아니라 그냥 절벽으로.
So it's gonna something like this. So it's something like this. Yeah.
꺾이는 점이 없이 그냥 절벽으로 계산돼.
Yeah, in that way, yes. Basically, here you just show it, but it's not your budget constraint. It's not your budget line because you cannot borrow it from the future. If you can borrow from the future, then it's possible. You cannot borrow it. Yeah. Okay, know what I mean? So obviously, in this case, since we assume that there is no borrowing using your future pension, so this case is just not possible. The only case possible is this on this line, and then it stops here. So
통의 경우는 다 절벽으로
basically, yes. Yeah. Yeah. Any questions about this? No, I use crowding out just simply means that public pension will just replace at least a part of the private saving. Then I just say it's crowding out. Any other questions about this one? Yeah, it's totally possible. So you can, if you can borrow your money from your future, yes, you can have any point on this.
아무런 일이 없으면 그래프를 그릴 때 지원 스탄스는 꺾이는 부분에서 공통점인 부분에서 그냥 절벽으로.
Yes, if there, let's say hypothetically on the exam, then if there is anything, then you just assume like our lecture note. If you need to make another assumption, then I will clearly write down that there's a different assumption there. Okay, so the first thing is that this is a probability that a person gets employed, unemployed. Arrival rate times that offer exceeds the probability of job offer times probability that the job offer exceeds the reservation wage. If both conditions are met, then this individual will just take the job and become employed. So expected duration is just 1 over this probability. So when you see just this, then when the lambda increases, job arrival rate goes up, then this duration should go down, right? Expected duration, or you can say average duration of individuals will go down if lambda goes up, okay? But the thing is that when the lambda changes, then the reservation wage will change as well. Okay? How? If there is a lot of job offers coming to your door, so then your idea is that, okay, if I wait for another offer, then I have a very high probability of getting another offer, then this another offer is, can be pretty good. So the individuals will think that, okay, I need to set my goal higher because I will get lots of job offers. Okay? Which means that if the lambda goes up, then reservation wage will go up. Okay? So if you look at only this part, if x is high, then probability of getting an offer that exceeding x is low. Okay? So if lambda goes up, then you increase this probability, but you also decrease this probability. So at the end, it may increase or decrease the change of lambda.
그럼 unemployment duration이랑 job search duration이
Same, yeah. Because in this here is that unemployed person is automatically searching for a job. Okay, unemployment, job search, basically it's the same thing.
그래서 다음 슬라이드 맨 마지막 줄에 ambiguous effect를 있다는 그 말.
Right, exactly. So arrival rate may increase or decrease the job search duration depending on how this TU changes. Okay.
단순하게 어라이벌 레이트가 올라갔을 때 그러니까 자본거가 오는 빈도가 많아지면은 그냥 바로 선택을 하면은 듀레이션이 짧아지는 거고 그냥 계속 기다리면은 듀레이션이 길어진다고 보시면
Yeah, in that way, so for example, like an increase of job arrival rate, let's say increase your reservation age by a lot, then it's likely that your unemployment duration will be longer. Okay, but if the effect is small, then probably shorter.
근데 그 empirical finding에서는 그 arrival rate가 duration이 employment을 결정한다고 돼 있는데 그거는 시험 문제에 나오면 이론적으로 접근해야 되는 거 아니에요?
Obviously, it should be the first theoretical aspects. Okay, so empirical aspects is that actually, so quite often that people wonder that what is the reservation wage for people, and then they try to find out, but it's very difficult to find out because you will never see it. Because reservation wage is in each person's mind. You just don't know. So when they try to estimate it, then it turns out to be very, very low. I mean, it should be low, I mean, when you estimate. Well, I'm not going to go into detail in the estimation. So the estimation kind of implies that reservation wage is likely to be very low. So, which means that the almost all offers are higher than the reservation wage. Okay, so it means that practically this is 1. Okay, if x is very low, then this is almost 1. Then what matters is only lambda. Okay, questions? Any other chapter? Questions? Okay, then can you finish here? Okay? Everyone's okay? Any question? 네, 뭐?
14년도 거 한 번에 보면
뭐 했어?
이게
Okay, this is the one that I could not cover yesterday. This is the last topic of the lecture. If you want, I can explain now. Yeah, but it's not gonna be on your exam because I couldn't cover it yesterday. This is a way of decomposing wage gap into the part that is explained by human capital difference and other factors. The other factors is likely, it's considered to be discrimination. So just that the way of separating them. Okay, so that one is just using that theory that calculates each number. 4번? 잭 앤 질? 네.
A의 조인트 유틸리티가
Yeah, this means couples utility. Yeah. Joint is together, so utility of together. Yeah, it's nothing. It's just a. Oh yeah, it's I mean, in any way that when you have a higher budget line, you will always have higher utility. Okay. Think about it. I mean, think of the budget constraint. When you have a higher budget line, you will have always higher utility. So A is just means that there are two ways of drawing the budget constraint I explained in the lecture, right? One is that Jack goes out to work first and Jill goes out to work first. So, find which one gives you higher utility, which means that find which one gives you higher budget line. Okay, it's whether. No, it doesn't matter. It's just that depends on consumption. So, and this is what we have done in the class. Yeah, pretty similar.
내셔널스 인슈런스가 그 프라이빗 인슈런스 마켓에서 일어나는 모럴 해저드도 결국 해결할 수 없다고 하잖아요.
Yeah, I think that's what I said. Yeah.
그러면 솔브할 수 있는 방법은
네?
여기서 기출에 보면 discuss how the manufacturer private insurance가 어떻게 솔브하는지 쓰려는데
You can write, you cannot solve it. Yeah. If you think it's, no, is there a way? No, I don't think you can solve it. Just you can write down that there is no way. Questions?
교수님 그러면 시험 문제 풀때 그거를 될 때 어떤 이론을 설명하게 되면은 그 문자 같은 것도 하나하나 다 이름을 새로 써가지고 그러니까 예를 들면은 페이아웃을 Z라고 여기 프린트에 돼 있으면은 그냥 처음부터 Z라고 쓰면 되는지 아니면 일일이 이게 다 뭐 페이아웃은 Z고 이렇게 다 써야 되는지 노테이션 다 해주는
The thing is,
시간이 너무
if I no the is this. I mean, so when I read your answer, if I know what it is, then it's okay. Let's say if I use, let's say, C for consumption in my question, you don't have to explain C is a consumption again. C, I know that C is a consumption. Okay?
람다 이런 거는 써야 돼.
Yeah, I mean, you cannot just write down lambda and then without saying anything, If it's lambda, let's say use an arrival rate or something. Yeah, I mean, if it's in the question, yeah, you can just use the same notation. But if it's, say, not in the question, then you want to introduce new thing to your answer. Yeah, it's good to write what it is. Okay. But if you have no time, probably you can skip it if you believe that I know what it is. Probably I know what it is. When you write down job search model and use lambda, then probably I know what it is. Yeah, I believe I know. Yeah. But if you write down alpha, then probably I don't know. So that's a problem. Okay. Yeah, it doesn't matter. Yeah, if that's the case, it doesn't matter.
그 모델에서 질은 하우스 마켓 워크만 하고 근데 그런 경우 세 가지가 있었잖아요. 그러니까 잭이 마켓 워크랑 하우스 워크 둘 다 하고 질은 하우스 워크만 하는 경우도 있었는데 왜 잭이랑 질이 둘 다 하우스 워크랑 마켓 워크 같이 하는 경우가
Yeah, because that I mean that's the structure. Like in that particular model, it's true that because there's always a person who goes out to work first. So the second person engaged in market work only after the first person exhausts all the time into market work. So that's how the market works. If you want the market that they can choose both, I mean obviously you can have it, but not this one.